Welcome back to Hidden Truth Diaries. This is the channel where unanswered questions, forgotten technologies, and hidden histories are explored beyond the surface. Today, we're uncovering the truth about the unique technology of the Concorde, a jet so advanced, no airline has matched it since. Decades ago, passengers crossed the Atlantic faster than the rotation of the Earth itself. No stopovers, no waiting, just speed. This wasn't science fiction. It wasn't experimental. It was routine. Yet today, not a single commercial airline can do what this aircraft once did. Because the truth is, the Concorde wasn't just fast, it was too advanced. If you're fascinated by lost engineering, aviation secrets, and the truth's history left behind, subscribe now and join us. The Concorde wasn't just faster. It was a flying laboratory of unique engineering and luxury features born from the extreme demands of supersonic travel. Here are 5 of the unique features that made it truly one of a kind. Number 1. The speed that still hasn't been matched. If this intrigues you and raises the questions of why and how, hit the subscribe button as those questions are answered. The Concorde didn't simply break the sound barrier. It lived beyond it. Cruising at over Mach 2, this aircraft sustained supersonic flight for hours, not minutes. While modern jets creep across the sky at subsonic speeds, Concorde outran its own sonic boom. At cruise, the skin of the aircraft heated to over 250 degrees Fahrenheit. So hot, the fuselage physically expanded mid-flight. Pilots could measure the change inside the cockpit. No modern passenger aircraft experiences this. Not because we forgot how, but because we decided it was too costly to continue. The droop nose. Engineering over software. One of Concorde's most recognizable features wasn't about speed. It was about sight. The aircraft's long, slender nose blocked the pilot's view during landing and takeoff. So engineers didn't add cameras. They didn't add screens. They redesigned the aircraft itself. The droop nose physically lowered, mechanically, giving pilots a clear view of the runway. No automation. No software correction. Just engineering you could trust with your eyes. There is no doubt your mind is being agitated by some questions. If so, hit subscribe and please drop your questions in the comments section while I answer the most probable question regarding the droop nose of Concorde airplane. Why no other airline has it? No other commercial airliner needs to solve this specific problem. The nose drooped 5 to 12 degrees during takeoff and landing so pilots could see the runway. At cruise, it was raised for optimal aerodynamics, and the visor retracted to protect the windshield from the intense frictional heat up to 127 degrees Celsius, 260 degrees Fahrenheit, of Mach 2 flight. Number 3. In-flight fuel transfer as a primary flight control system. On most airplanes, fuel is simply burned. On Concorde, fuel was controlled. As the aircraft accelerated past the sound barrier, its balance shifted. To compensate, pilots actively pumped fuel between tanks. Front to back to front via a complex system of fuel tanks and pumps. While I must tell you the why of the uniqueness of the fuel control system of Concorde airplane, don't forget to comment, hit subscribe, like and share. Why it's unique. As the Concorde accelerated through Mach 1 and the center of aerodynamic pressure shifted, the plane would become nose heavy. To compensate, over 2,000 gallons of fuel was automatically pumped from the front tanks to a rear, trim tank. No subsonic aircraft requires this for basic flight control. The pilots also used fuel transfer for fine-tuning balance during descent. Fuel wasn't just consumed. It was repositioned to keep the aircraft stable at Mach 2. No modern airliner demands this level of pilot involvement. It's considered too complex. Concorde demanded precision. The analog cockpit that never lied is the 4th of unique features that made the Concorde airplane stand out till date. Step inside the Concorde cockpit, and something feels different. No glass screens. No digital overlays. Instead, rows of analog instruments. Each one precise. Each one honest. There was no software hiding mistakes. What pilots saw was exactly what the aircraft was doing. In an era before automation dependency, Concorde pilots flew with raw data and absolute responsibility. It's a level of connection modern cockpits no longer offer. Number 5. The secret power of the air intakes. Here's something rarely mentioned. At supersonic cruise, most of Concorde's thrust didn't come from the engines. It came from the air itself. Variable geometry intakes slowed incoming supersonic air, using controlled shockwaves before it reached the engines. The intake system generated thrust of its own. This process was so efficient that the intake system acted like an engine of its own. Modern jets don't do this. They don't need to, because none of them fly fast enough for air to become both obstacle and power source. Perhaps the question on your mind now is why no airline has brought this back. Or why hasn't this technology returned? Not because it's impossible, because priorities changed. Fuel became expensive. Noise regulations tightened. Sonic booms were no longer acceptable. Passengers chose affordability over speed. An aircraft built for prestige, performance, and ambition no longer fit the modern business model. Concorde didn't fail. The world moved on. Nevertheless, the Concorde's unique features weren't gimmicks. They were ingenious, necessary solutions for taming the physics of sustained supersonic passenger flight. They collectively illustrate why its return is so complex. It wasn't just an airplane, it was a specific, daring, and fuel-hungry concept that has yet to be matched. Here is the kicker: the legacy. The Concorde was never just a plane. It was proof that humanity could bend physics to its will. Today's aircraft are safer, more efficient, more economical. But none of them fly with the audacity Concorde once did. We didn't lose the technology. We chose a different future. So the question remains: if supersonic travel returned tomorrow, would you fly it? Comment, "Yes, I will fly a Concorde," in the comment section. If you're drawn to mysteries, aviation secrets, unexplained events, and stories that challenge what we think we know, you're in the right place. Subscribe now and join a growing community that values curiosity, depth, and clarity, because some truths are too important to ignore.